Welcome students. So far we have discussed about the one type of mixture, that is solutions. Now today we will discuss about suspensions. See, we have just studied that the substances which are soluble in water or in other liquid, they form solutions. But those substances which are insoluble in water, they form suspensions. So, suspension is a heterogeneous mixture in which the small particles of solid are separate throughout the liquid without dissolving in it. It means that are insoluble in that liquid and form heterogeneous mixture. You know that heterogeneous mixture means the mixture which is not uniform throughout, which are having visible boundaries of separation between the constituents, right? So, suspensions are heterogeneous mixtures, and the small particles of solid are spread throughout a liquid without dissolving in it. If we look for the common examples of suspensions, we are having chalk water mixture, muddy water, milk of magnesia, sand particles suspended in water, flour in water. So, these are all heterogeneous mixtures, these are all suspensions. If we talk about chalk water mixture is actually a suspension of fine chalk particles in water. Similarly, muddy water, it's a suspension of soil particles in water. One more suspension is milk of magnesia. Milk of magnesia is a suspension of magnesium hydroxide in water. So just remember that solid particles and liquid or solid particles and water, they remain separate in a suspension. That is why I told it's a heterogeneous mixture, because the constituents are separated. So particles that do not dissolve in water. Now, if we look for the properties of suspension, so let me tell you that the important characteristic property of suspension, the first one, that a suspension is a heterogeneous mixture. It means the mixture is not uniform, it has visible boundaries of separation. Okay. Another property of suspension is that the size of solute particles in a suspension is quite large. That means the particles are quite large, we can see them by naked eyes. That means the particles of suspension can be seen easily. Suppose if we shake some chalk powder with water in a beaker, a milky suspension is formed, right? So we can see the fine particles of chalk suspended throughout the water without dissolving in it, right? So basically, particles are quite large. We can see them easily, and the particles of suspension. Size of solute particles in suspension, it's actually larger than 100 nanometer. Size is larger than 100 nanometer. Okay. So this is the size of solute particles. It's quite large, so we can see them easily, okay, by naked eyes. Another property of suspension is that the particles of suspension do not pass through filter paper. It means a suspension can be separated by filtration, right? Because when the particles do not pass through filter paper, it means we can separate them by filtration. If we pass the suspension of chalk and water on filter paper, you will see that the chalk particles which are insoluble, they are left behind as a residue, right? They are left behind as a residue on filter paper, and clear water is obtained as a filtrate. So this means we can separate the suspensions by filtration. Okay. Another important property of suspension is that the suspensions are quite they are unstable. Now, what do we mean by unstable? As in case of solutions, I told you that the solutions are stable. That means if the solution is left undisturbed, particles will not get separated out, right? But in case of suspension, suspensions are unstable. It means the particles of suspension settle down after some time. That means if we keep the suspension of chalk and water undisturbed for some time, you'll see that the chalk particles, they will settle down at the bottom of the beaker, right? So this means chalk and water suspension is unstable. Clear? Another important property of suspensions is that the suspensions scatter a beam of light passing through it. It means whenever a beam of light passes through a suspension, as you can see here in this figure, in this diagram here, if a beam of light is passed through a suspension, passed through a suppose chalk water suspension, you will see the beam of light, you will see the path of light through that suspension. It means path of light becomes visible. Why? Because the particles of suspension scatter the beam of light and renders its path visible inside it. So we can see the path of the light. So particles actually scatter light. But why the particles of suspension are scattering light and not the particles of solution? Because solutions, they do not scatter light. Because the particles present in solution, they are actually very small, less than 1 nanometer. But the particles of suspension are quite large. These are greater than 100 nanometers. So particles are quite large. So they are able to scatter a beam of light passing through it. So these were all properties of suspension.